Unit 4, Day 2. Suppose the number of M&Ms in a 1 pound bag has an approximate normal distribution with a mean of 550 and a standard deviation of 12. Okay, so we're going to put that in math words. So we have a random variable, x, that represents the number of M&Ms in one bag, and x is approximately normally distributed with a mean of 550 and a standard deviation of 12. And then I drew my picture. And the notes are claiming that we could draw this picture on the calculator, and we can. We won't usually use it. And it says to use the normal PDF distribution. What this does, it gives us the height of the curve, or the probability of getting a bag of M&Ms with that specific number of M&Ms for each type. And we normally won't use this because this really isn't continuous, right? A bag of M&Ms is going to have 550 or 551. They usually aren't halves in there, so it's more discrete data. And so what we do is we go to y equals, and then we're going to put this in. The way you get normal PDF is in this distribution area, and I'll show you that in a minute. But if you hit graph, there it is. Okay, this value right here is 550. That's the middle. And if I wanted to know, okay, the height of this graph at 550, second calc value at 550, it is 0.03, okay, which is about 3%. That means the probability, so that 0.033 means the probability of getting a bag of M&Ms, you randomly grab a bag and actually have the mean, which is 550, is about 3.3%. If this was continuous data, so measuring stuff, that probability would be 0. Even if you put it in the calculator, it'll give you percent. It's actually 0. So we don't use this a lot. Okay, the other way to do that would have gone to second distribution, normal PDF. And yours should prompt you, this is my older version. Here you put how many M&Ms you're looking for, comma, the average number of M&Ms, so I'm just using both for my example, comma, 12 is my standard deviation. And I should not have put that there. Sorry, I had to get out of the y equals screen. You put that in, and it'll tell you it's about 3.3%. We won't use that very often, but it's just kind of interesting. Okay, instead, we'll do stuff like this. So it says, let's answer some questions. What proportion of bags will have fewer than 525 M&Ms? Now we're talking about this. We would draw our picture, which is up here, and we want to know the probability of having fewer than 525 M&Ms. So that's right about here and over. Okay, so what we do is we go to our calculator, and we want the cumulative CDF, which means it'll add up the probability of 25 M&Ms, 24 M&Ms, 23, 22, 21, 514, 513, 511, all the way down to negative infinity. And that'll be the probability of having 525 or less. So you go second distribution. Your newer calculators will prompt you at this point, normal CDF, and you tell it its lower boundary. Well, this goes to negative infinity. You can enter in negative infinity. It is negative 1, let's see where it is, e, whoops, that's not it, e to the 99. But you don't need to do that. You can just put a really large or really small number. And we want it to go up to 525. And then we tell it the mean of our distribution and the standard deviation. In this way, we do not have to convert to z-scores because the calculator will do it for us. And it says the probability of that is 0.0186, okay, or about 1.9%. So what I did here was I showed the amount of work that you would have to show, and it's equal to 0.0186, or about 1.9%, right? Chance of that, which makes a lot of sense because we are a full 2 standard deviations away, okay? And you have to write it like this. The probability of x being less than 525 equals, and then you show how you get it. They will take calculator speak, but only if you label what everything is. So you were at negative infinity up to 525 with a mean of 550 and a standard deviation of 12. Okay, you have to label like that. Let's try another one. Okay, and that's what they put right here for you. So you have this. Note, read it again, to get full credit you must define the variable, we did that up top, state the distribution, we did that up top, sketch the picture, state the question, that's stating the question right here, how you got the answer, and the answer. You need all of this. I'm going to put a huge star there to get full credit on a free response exam. All right, so for number 3, it says, what proportion of M&Ms will have fewer than 600 M&Ms? So since we're on a new page, I went ahead and defined the distribution again, drew my picture, and I have yet to state the problem. The problem is what's the probability of having more than 565 M&Ms. Okay, and so we have 550, 565 is going to be like, oops. Notice that I skipped down one problem. We'll go ahead and do this problem and then go back up top. Okay, 565 M&Ms, so that's going to be here. 565, you draw on your picture, and then this is what I put in my calculator. Okay, let's go to the calculator. Second distribution, normal CDF, because we want to add up all of these probabilities right here. Okay, our lower boundary is 565, comma, now I could do 1e to the 99999, but I'm just going to do a really big number, because that's close enough to infinity. 550 mean, 12 standard deviation, and hit enter. And what did I screw up? Oh, notice I went to inverse norm. That's not the right one. Second distribution, I went down one too many. I want normal CDF. So 565 to infinity with a mean of 550 and a standard deviation of 12. And you should get about 0.1056 or 10.56%. So that's that problem. Now let's skip back up to the top one that I skipped. Right here. Okay, I'm showing my work, but I still need to state the problem first. I'm going to do this one blue. It says, what's the probability of having fewer than 600 M&Ms? So that's like all the way up here. So good chance of that, right? Because on average you have 550, 2 standard deviations is 574. There's a good chance of having fewer than, say, 500. Or so use me, 600. So my question is, what's the probability of having fewer than 600? All right, so this is again what I would put in the calculator. Negative infinity to 600, 550, and 12. And if you do that, the calculator should give you about 99.998, which makes a lot of sense, because really 600 is like almost all the way up here. So there we go. Okay, let's try a few more of those, because you'll have to do this all year for everything we do. What proportion will have between 530 and 570? So this is 538, so this would be about 530, 50, 560, 574, so, and 570. We need this proportion in here. And again, I got a little lazy because my stylus isn't working. You should label these standard deviations as well. Okay, so state my problem. The probability of having between 530 570 M&Ms. We're going to put it in my calculator. This time our lower bound is 530, our upper bound is 570, and if you do that, you should get about 90.4. Okay. Now let's try this one. What is the 30th percentile for this distribution? This is something new. What we're asking is where does it fall to get 30% under the curve. So, I don't know, maybe here. Okay. We need this to be 30%. If we were to break this up into thirds, maybe that's 30% of it. Okay. So we're looking for this value here. So instead we're going to use something different, which is inverse norm. Alright, and what we put in the calculator is this right here. And we would have to state our problem. We want the probability of x less than some number a being equal to 0.30. And then we put this in our calculator. So this is the area under the curve, or percent under the curve. This is my mean. Remember, you have to label them. And this is my standard deviation. And let's try that. So basically, this time you give it the percent and it gives you the cutoff. Before you gave it the cutoff and it gave you the percent. So second, distribute. This is that inverse norm. We're doing it backwards. The first thing is the percent, comma, 550 is my average, the standard deviation of 12, and about 543, so I guessed well. So the answer to that is A equals 543.7 M&Ms. Now you could round that to 544, but for accuracy's sake, we'll leave it to 543.7 M&Ms if we were going to plug it back in. And you could check by going the other direction. Okay, stat, and this is why you'd leave it this, distribution. This is why you would leave it this accurate. You'd say, what do we get if we go from negative infinity up to 543.7, the mean of 550, and a standard deviation of 12. And sure enough, we get about 30%. So that's the other direction. All right. Next it says, what is the interquartile range for this distribution? Well, the interquartile range goes from Q1, which is 0.25, to Q3, which is 0.75. And so we need to find the cutoffs for that. Okay, so we need to find the cutoffs for 25% and 75%. And I'm pretty good at estimating this, so my guess is that this is going to be the cutoff for 25. And this is going to be the cutoff for 75. Okay, and we're trying to find some point A and some point B. We want so we can subtract them and get this range in between, right? Because interquartile range is Q1, or sorry, excuse me, Q3 minus Q1. So we are just going to put those directly into the calculator just like we did before. For this red one, this will give us the red. Will give us this percentage. Okay. And the blue will give us this percentage. And then if we subtracted the two, we should get the middle. I am going to go ahead and pause there because it's running out of time, and we'll start on part 2.